Hi, this is Dr. Eddie Morgan over at Clovis East High School, here to help you with your homework tonight. This is the Math 1 homework, worksheet 2.3b. Remember that each of the problems on the homework help is almost identical to the problem on your homework assignment itself. So for example, you're having a problem with number 3. Fast forward this video to problem 3, watch the video, and you should have enough information then to be able to do the problem on your assignment. All right, good luck. In the first 6 problems, we're given a graph, and we're simply asked to identify, is it a linear function, which means a straight line? Is it a quadratic function that looks like a U? Is it an exponential that keeps rising or keeps declining? Or is it an absolute value function, which has that shape, or a piecewise, which can be put together? So as we look at this one here, notice that this shape, it starts here and it just continually rises. When you have something that continually rises or continually declines, it's either linear or it's the exponential. The exponential is curved, so in this case our answer is this is an exponential function. On the other hand, here it constantly is going down, and again, if they're always going down or always going up, but neither both, it's either a linear or exponential. But if it's a straight line, then we know this is our linear function. Okay? Exponential function and linear function. Problem 3, this part looks like a line, this part looks like a line, and this part looks like a line, but they're not exactly together. So when you have different pieces put together, this is a linear piecewise function. Problem 4 has our typical U shape. When you say the U shape either that way or this way, you know you're dealing with a quadratic function. So look at problem 5. You notice on the one hand that this is a straight line. So you can say that this is a linear function. All right. We do distinguish, though, one particular kind of linear function, and that's the linear constant, because notice that whatever x is, y is always the same value. So when we have a horizontal line, we call that a linear constant function. It is a linear function. It's a subset of that, a linear constant function. And finally, our last one has that V shaped. So it looks like two lines put together, and the angle here is the same as the angle here. It goes in and goes out. And this is classically our description of a linear absolute value function. And you remember the absolute value function, and you can see that if you look at just absolute value of x, as you start on one side, you're going 10, 9, 8, 5, 3, 2, 1, 0. And then when you get to -1, it starts going back up again. And that's what gives it this kind of dynamic look like that of a V shape. On the next set of problems, 7 through 14, we're simply asked to look at the equation and tell what kind of graph it is. Key thing to look at here is what's happening to the x. If you notice here, my x is all by itself. There's no x squared, there's no x cubed, there's no absolute value function. And when you have a single x, sometimes we would refer to this as x to the 1 power. This is a linear function. You're going to see a lot of linear functions in this unit and the next unit. On the other hand, when you look here for the x, notice that this is -2 and the x is in the exponent. So that's an exponent, so guess what function this is? This is the exponential function. It's pretty simple. Problem 9, find the x again, and notice that this time it's x squared. Whenever we have an x squared account, this is the quadratic. Has a little bit like that linear absolute, because every time an x squared, remember that 2 squared is 4, but so is negative 2 squared is 4. And that's why you get this coming down this way and then going back up, because once you get to the negative numbers, they start being positive as well. On the other hand, the next one is y equals 8. Notice that there is no x function here at all. The x is gone. In this case, if you were to graph it, notice here, when x is 0, y is 8. When x is 1, y is 8. When x is 2, y is 8. And likewise, negative 1. And here, in this case, there's no x, and this is our linear constant function. So what makes this different from the other linear functions is you notice there's no x in the equation. It's just always constant, and we call that the constant function, linear constant function. Once again, find the x. What's happening to the x? Well, notice there's a negative, but more important, it's an x squared. Again, x squared, we're thinking quadratic equation or quadratic function. In problem 14, where's the x? Oh, it's up in the exponent again. Okay, even though that's a 1/3, it's 1/3 to the x power. So this is an exponential function. In our next problem, you notice that there's a couple of different equations. It says when x is less than 5, it's going to be 2. And when x is greater than 5, it's going to be 3/4 x. In other words, if I'm graphing this and I go out here to 5, when x is less than 5 that way, it's simply going to be a constant function that looks like this up to that point. At the next point, though, it's going to be 3/4 x minus 2, which is going to be a linear function that's going to take off like that. So notice what I have is two lines put together, two pieces put together. So this is the linear piecewise function. Now, number 14 should be easy to see. Find x, there's x, and notice these bars. Those are absolute value bars. So whenever you see that, you know you're dealing with an absolute value function. For the next 6 problems, it's similar to what we just did. We're going to look at these functions up here and match them to what kind they got below here. So we're doing the same thing, we're just matching. So my first one here, I see my absolute value function. So I'm going to write this down under absolute value. So I'm going to write down here, f of x equals absolute value minus 2x minus 3. Second one, notice I have an x there. It's not squared, no absolute value. It's not an exponent. So this is going to be a linear equation. Third one, there's my x in parentheses, but notice the squared. The squared indicates that this is a quadratic. And now here, if I were to multiply this, notice if we multiplied this, we'd get 2x minus 12. And at that point, you can see the x is by itself. It doesn't have an exponent, doesn't have any of that, so this is another linear function. Number 3, we've circled it because this one is actually a cubic. And we're not studying cubics. Notice instead of being squared, it's to the 3rd power. That's a cubic function. If you're interested, it kind of looks like this. But we're not studying that particular one. On our next problem, notice there, x squared. X squared means quadratic. Notice here, this says y as opposed to f of x. Those are kind of interchangeable. You use the f of x when you're emphasizing that it's a function where the independent variable is x, but you'll often see functions written as y. So there's my x squared that makes it a quadratic. Finally here, notice there's no x at all. No matter what x is, it's always -1, So that is our linear constant function. And then down here, you should identify this one. Notice I have when x is less than 1, it's 1. When it's greater than 1, it's another line. So what I've got here is that where I got a line and a line. So this is a linear piecewise. Notice it's made up of actually two different equations, depending on what x is. When x is less than 1, y equals 1. When x is greater than or equal to 1, then it's 2x plus 1. So that's a linear function. Here we have y equals 5. Again, there's no x, so it's kind of like this one here. It's a constant function. And then finally, notice here, two different equations, two different linear equations. So this is our linear piecewise. And the one that is missing here, oh, nope, I'm sorry, we missed one here. I didn't realize we missed one here. Notice here, my x is in the exponent, so that's my exponential function. X is up there in the exponent, okay? So again, you need to be able to identify these either by the equation or by the next couple problems. Ask us to look at these four categories: linear functions, quadratic, exponential, linear absolute value functions. And then as we read the problem, listen to the characteristics and see which ones it might be describing. So 21 says the graph of this function is a straight line. All right? The only straight lines we really have are linear functions, and one that's not listed. If they listed linear constant function, that would be an answer as well, but we're only doing these four up here. 22 says the graph of this function has an increasing interval and a decreasing interval. That means it goes up sometimes and go down sometimes. Well, there's two possibilities here. I could have this one here, that's the quadratic function. So it could be a quadratic function, but it also could be this one here with the straight lines, and that's the absolute value function. So two possibilities for that one. (23) says the graph of this function has an absolute minimum. Once again, there's two answers here. I could have a negative quadratic that goes down like that. There's an absolute minimum there. So it could be a quadratic. Or, once again, it could be the absolute value opposite that way. So there's two answers for that one. (24) says the graph of this function is decreasing over the entire domain. So it's always going down. Well, in this case, there's actually two possibilities. First of all, it could simply be a line going down. So we have our linear function. But another function that's always going to be decreasing is the one that looks like this. And that's an exponential function. (25) says the graph of this function forms a V shape. Well, the only V shape, this one, there's only one V shape, and that's our absolute value function. (26) says the graph of this function has an increasing interval and a decreasing interval. Now, we had that before, and we realized it could be a quadratic or an absolute value, but this time it says it also has a U shape. So it's increasing and then it's decreasing in a U shape. So this is our quadratic function. (27) says the graph of this function does not have a maximum or minimum and is a smooth curve. So in this case, there's a possibility. It has a smooth curve, so we can count out a line. There are two possibilities here. One is an exponential that goes this way. The other is an exponential that goes this way, decreasing. Both of them are exponential functions. A line doesn't have a maximum or minimum either, but a line's not a curve, so that's why a line doesn't work here, only exponential. The graph of this exponential has a maximum or minimum, but it's made a straight line, so it's going to have a maximum or minimum. And if it were just maximum or minimum, we saw above, it could be quadratic or absolute value, but in this case, because it has straight lines, it can only be one of these two. There's a minimum, there's a maximum, and those are absolute value functions. (29) says the graph of this function is made up of straight lines, doesn't have an absolute maximum or minimum, and the function family is just going to be our lines, linear function. Now, it is possible that it could be linear piecewise, although that's not an option. If you had something like this where it doesn't have a maximum or minimum, but that's not one of our options up here. Finally, the graph of this function decreases over the entire range and is a smooth curve. Okay, so this one decreases. It's always going down as a smooth curve, not a line, so this is an exponential function. If it were a straight line decreasing, it could be a linear function. For the next couple, it asks you to create an equation and then sketch the graph. In our case, we asked you not to worry about creating an equation, but to sketch one of the graph families. So in this case, I need a smooth curve that's continuous, and it has a minimum and is quadratic. Actually, that's the key thing. Can you draw a quadratic equation? So for example, I'm going to draw a quadratic equation right here. This is actually the equation, simple one, y equals x squared. Notice it has a minimum, so that's why I drew it this way, a positive quadratic. It is a smooth curve, it never stops, and it has a minimum, and it's a quadratic. Number 32 says it's linear, and notice it's discrete, and it's decreasing. So the linear means it's going to be a straight line. Decreasing, it's going to go down that way. So for example, I'm going to create the equation y equals minus x plus 2, which means it goes through the line here, and then it goes down 1 and over 1. And I'm just going to make the dots like this to make it discrete. And so this would be a sample of a discrete linear function. Discrete, again, simply means the points aren't connected. They're separate pieces. So that's a linear discrete function, and it's decreasing over the same domain. Remember, when we say increasing and decreasing, we mean like you read it from left to right, it's going down. 33 says it has a smooth curve. It's increasing across the entire domain. It's continuous. And key thing, it's exponential. So I'll give you a sample here. This is a very simple one. Y equals 2 to the x. When x is 0, anything with the 0 power is 1. So it goes through there. When x is 1, 2 to the 1 is going to be 2. But now we get 2 squared, it's going to go up to 4. And then 2 to the third is going to go up to 8. Likewise, to the negative 1 will be 1/2. And you can see this is our exponential function that looks like that. Again, you do not have to create the equation for us at this point, but you do need to be able to show me an exponential function that's increasing and continuous. 34 says sketch a graph that has a maximum. Means it could be quadratic or an absolute value. It's continuous, and it's a linear absolute value function. All right? So I'm going to show you one, a very simple one. If I just did y equals absolute value of x, that would look like a V shape. I need it to have that would be a minimum. I need a maximum, so I just change it to negative. So in this case, when x is 0, y is 0, but then it goes down like this. When x is 1, it's minus 1. When x is negative 1, it's minus 1. Problem 35 says it's linear, it's continuous, but it's not increasing or decreasing. So it's not going up and it's not going down. So what we have here is that's going to be constant. The only other thing it tells us is it's not going to go to the origin, so it's not going to be 0. So for example, if I were to graph y equals 3, see 1, 2, 3, no matter what x is, it's 3. That's a constant function. And the last one in this group says it's discrete, so I'm going to draw my dots. It's got a maximum, so it's either going to be this one or this one. It doesn't go through the origin, that's 0, 0, but it tells me it's a quadratic, so that means it's going to be that one. So for example, I could draw, if I have an x squared, it's going to go like this. So to make it go the other way, I'll make it a negative x squared. Normally x squared would go through the origin, so I can't leave it there because 0, 0 would be, so I'm just going to add 3 to it. Again, you don't have to write the equation, you just got to have to know. So mine's going to start up here at 3, and then it's going to go down like this. And that's a quadratic with a maximum. Notice there's a high point there, and it doesn't go through the origin. 37 asks us to look at the graph here and decide which graph matches it. Well, first of all, I notice that it only has an x. So that means it's a linear equation. So I can immediately cancel that because that's exponential. Now I just have to decide this one, it's going up, and this one's going down. All right? There's two ways to do this, actually. First of all, I could say, is it going up or down? And that's when I look at the slope. Notice the slope is 2/3, which is positive. So that means the line is going up, so that's my answer. And not here. This one's going down. The other way I could have looked at it is when x is 0, it's 1. And notice 0, 1 is an answer, whereas over here, it went through the 2 point. So that would be another way to see it. Here, my m is positive 2/3, and my b, where it crosses, is 1 that match up there. Whereas over here, the m looks like it goes down 1 for every 2, so it's negative 1/2, and the b is actually 2. This would be the equation y equals negative 1/2 x plus 2. Problem 38 is a little easier. When I look at the equation, I notice it has an x squared. The moment I see the x squared, I know this is a quadratic. And quadratics look like this or this. So my answer is C. 39 is also fairly easy because when I find the x, notice it's 2 and the x is in the exponent. So that means this is an exponential function. And if I remember how an exponential function looks, it's curved, constantly increasing or constantly decreasing. In this case, 2 is positive, so it's constantly increasing. Number 40 should be fairly easy too. Notice we have the absolute value sign, the brackets there. So this is going to be an absolute value. And absolute value either look like this. They either look like a V or a V, and you notice C is our answer. Now as we look at this next one, we notice that x here does not have an x squared and x cubed. There's no absolute value. So we know this is a linear equation. And we see two linear equations here. This one's obviously out, but the other two are linears. And here's the key for here. X is an integer. Okay? So x is an integer means we're only using the 1, 2, 3, 4, 5, nothing in between. And so it's not going to be continuous, and our answer is A. Because we're only finding when x is 1, when x is 2, when x is 3. So when x is 0, this is minus 3. When x is 1, this is negative 2, etc., etc. It's a discrete form there. Our final one says f of x equals negative 2. So notice there's no x. So with no x, f is always going to be that answer. So the answer is this is a linear constant. And a linear constant just simply looks like this, a horizontal line. Now notice that means this is out, but we got two of them. So we simply have to find the one where x is -2. Notice here is 0, 0. So this is actually f of x equals +2. And we're looking for the -2, which is down here. So that's our answer. All right. So actually, even though this was a lot of paper, 5 pages of homework, you realize it really didn't take that long to do because we were just identifying equations and seeing if we could understand our function families. Good luck. See you tomorrow in class.